The next topic we're going to take a look at is function notation. That's section 4 on the worksheet if you're following along, or on page 7 there. I'm going to talk about this for a little bit and then we'll work out the problems that are on that worksheet. Okay. So we've said if we have a function, we can think of it as a machine. So let's suppose I have the function y equals x squared. Okay, so that would be the squaring machine. Okay. So when I plug in an x value x, what I get out is x squared. What I'm going to do is I'm going to give a name to that function. I'm going to call that function f. It's a very common name for functions because, of course, the word function starts with an f, although we can use any letter that we want to. And this output, we're saying that output is our y value, but we have another name for that that we can use. We can call it f of x. So I could write this, instead of y equals x squared, f of x equals x squared. Now, notice the way I'm reading this. This is f of x. It is not f times x. These are not two different things that are being multiplied together, although it sort of looks like that. We're using similar notation to what we use for multiplication, but this does not mean that. This is one symbol representing the y value that I get out. It's just a slightly more complicated symbol than simply writing y. What f of x means is it's the y value. It's just a fancier name for my y value. It's the y value I get when I plug x into this function, into the function f. So if I had multiple functions, maybe I've got another function that I'm calling g of x would be the y value that I get when I plug into that function. F of x is the y value that I get when I plug into this function. And sometimes students will say, well, why do we need this function notation? Isn't this just math teachers inventing notation to torture students? Because we've got a perfectly good symbol to mean our output. We can call it y. Why would we switch to this more complicated symbol? Because notice, this has 4 parts. There's f, left parentheses, x, right parentheses. Why would we use a 4-part symbol when we can just use a simple letter? Okay. Well, the notation is not there just to torture math students. It's actually fairly useful notation. And let me just show you with an example. If x is equal to 2, if I plug 2 in to the function f, where f is this squaring function, the output would be 2 squared. So I could say the y value would be 4. So there I've given you an ordered pair that would be part of this function. When x is 2, y is 4. Okay. So if I were graphing it, that would be this point 2, 4 that I would plot on the graph. But in order to give you the coordinates of the point using just x's and y's, I gave you 2 equations. One equation told you what x was, one equation told you what y was. If I use function notation, I can say it all in one equation, because I can say f of 2 is 4. This is saying the y value I get when I plug in 2 is 4. So there's my y value, and what's inside the parentheses here is my x value. So I can give you both coordinates for a point in just one equation. All right, so let's just practice using this function notation. So if I look at question 1 on the worksheet, it is f of x equals x squared. And the directions are to evaluate. Okay. And let's see, where did it go? Here we have it. Okay, part A was f of 2. So that's telling me that my x value is going to be 2. I'm supposed to plug that into the function. And what I need to do is figure out what's my y value. That's what I'm doing when I'm evaluating a function. Now, what I find it helpful to do is in the original equation here, x is really just a generic notation for my input. Okay. I'm going to just put it in parentheses. If it wasn't already in parentheses, because it didn't need to be, that's okay. But now I can see, okay, x is in the parentheses here. That's what I'm calling my input. Everywhere there's an x, that's where my input is, and then this is what I'm going to do to that input. I'm going to square it. So when I'm evaluating things, I can copy this formula, but in place of the x, I'm just going to put some empty parentheses. That's just a placeholder for my input. Okay. And then I can say, okay, whatever was in parentheses here is my input. That's what's going to go in that input position. So here, what's in parentheses is 2. That's my input. I'm going to plug in 2. And then 2 squared would be 4. So that's my answer. That's what I get when I plug in 2. Now, part B asks us to evaluate f of -3. So I'm going to do the same thing. I'm going to copy the formula for the function, but instead of writing x, I'm just going to put some empty parentheses as a placeholder for my input. And then whatever's inside of these parentheses, that's my input, that goes in this input position. Now, it's actually very helpful here that I had these parentheses. Here, they weren't necessary. This was helpful to see what I was doing, that I was just plugging in 2 to the formula. Here, it's necessary because x is -3. It has 2 parts to it. There's a negative sign, and then there's the absolute value of 3. I'm squaring x, so I'm squaring the whole thing. Very often when you're plugging in a negative number, it's going to be necessary to write those parentheses because -3 squared means -3 times -3, and that's going to be 9. That's the correct answer here. If I didn't write the parentheses, so this is not what it should be. If I didn't write the parentheses and I was just careless and I wrote this, this actually means -1 times 3 squared, because order of operations, we do exponents first and then multiplication. And a negative sign in front of a number just essentially means I'm multiplying it by -1. So this would be -9, and that's not what I get when I plug in -3. So writing the parentheses is a useful tool, I find, for telling me, hey, that's where I'm going to put my input. Whatever I'm plugging in, that I'm going to put inside of the parentheses. But it's also a necessary tool if you are plugging in a negative number to certain operations and you need to indicate that you're applying that operation to the entire number, the negative sign as well as the absolute value. Okay, there's a part C here. Let me just do that over here. Part C asks us to evaluate f of a. So they're not giving us a specific number, but they're telling us our input is a. Okay, well, I'm going to once again just copy the formula, but instead of writing x, that was just a placeholder for my input. So I'm just going to put some parentheses there. What's in parentheses here goes in the parentheses here. And so we just get a squared. So that is a little bit more abstract. That's just making sure we understand that what this is asking us to do is to replace the x's in the formula with this input. Sometimes we're given a specific number, sometimes we're given a variable, and then we just plug in that variable. All right, let's take a look at question 2 together, and then I'll have you try 3 and 4 on your own. So question 2, we've got the function g of x equals 3 minus 2x. Okay, and we're asked to evaluate g of -5, g of -5 plus h, and g of x plus h. Now that looks a little bit weird. We'll work through it together. Okay, so again, what I'm going to do is say this is just a formula for how I'm going to calculate my y values. That's the name that we've assigned for our arbitrary input. So whenever I'm evaluating the function, I'm just going to copy that formula, but instead of writing the symbol x, I'm going to just put some empty parentheses. That was a placeholder for my input. Now whatever's in the parentheses here, that's what goes in the parentheses here. So I'm going to put a -5 in here. And then I can say, okay, let's do the multiplication first. -2 times -5 is going to give me a +10. So this becomes 3 plus 10, which is 13. Now there, I went ahead and viewed this as a -2 times -5. If I wanted to, I could just do 2 times -5. That would give me a -10, but then I'm subtracting that. So subtracting -10 becomes adding 10. I went ahead and just worked with both negative signs to begin with. Okay. All right, the next problem looks a little bit more abstract. So I'm going to do the same thing though. 3 minus 2, and then let's give ourselves a placeholder for our input. Whatever was in parentheses here is going to go in parentheses here. So -5 plus h. The whole thing becomes my input. H here is just a variable that's representing some number. -5 is a specific number. H is a variable representing an arbitrary number. Let's simplify this, and then we'll talk a little bit more about why we might have an input that looks like this. So I want to break apart the parentheses to simplify this as much as I can. So I'm going to distribute, and I want to make sure I distribute both the 2 and the negative sign. So this is going to become 3 plus 10 minus 2h. And so that's 13 minus 2h. All right, now this is the sort of thing you're actually going to see a lot of in calculus. So let's go ahead and address what that means. If I were going to try to graph this function, we've determined that when we plug in -5, we get out 13. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have this lovely point, -5, 13. Okay. Now, you might remember that from graphing lines in previous classes that this is actually just going to be a line whose slope is -2. So we would go down to and over 1 and ultimately have a y-intercept of 3. So this is what the graph of that function looks like. Now, h is a variable, and it's a number that we're going to be adding to -5. H could be either positive or negative. Let's let it be positive for right now. So that basically says my x value is going to be h units away from -5. Generally speaking, when we use this in calculus, h is going to represent a small number. So it's basically saying, what happens if we go just a little ways away from -5? I know what I get at -5. Now what happens if I go a little ways away, h units away from -5? And what that's telling us is, well, at -5 we were at 13. If h is a positive number, and I were to go h units away horizontally, I would be going down 2h units from 13. So it's telling me if I change my input just a little bit from -5, what does it do to the output? The output at -5 is 13. The output, if I add h to my input, is going to be 2h less than what I had at -5. Okay, so basically when we've got inputs that look like this, a number plus a variable, it's saying what happens if we just go a little ways away from this point that we've already evaluated. Now, if we look at g of x plus h, that's going to be very similar, except that instead of having a very specific number that we're adding h to, now we're adding h to sort of a generic number of x. But I'm going to do the same thing. I'm going to say this is 3 minus 2, and then I'm going to put some open parentheses for my input. And whatever's in parentheses here goes in parentheses here. Okay, so I'm going to put an x plus h right there. Now that feels a little bit weird because I'm plugging in x plus h for x. I'm not saying that x equals x plus h and then trying to solve for what x is, because that just doesn't make any sense unless h is 0. I'm remembering that x here was just a placeholder. It's just a placeholder for my input. So this is a place where I find it super helpful to replace the x with these empty parentheses, because that way I'm saying what's in parentheses here goes in parentheses here. That feels more natural to me than saying I'm going to replace x with x plus h. That feels a little bit weird because x and x plus h are different things unless h happens to be 0. Okay. So remembering that x is just a placeholder for your input, if your input is x plus h, that's what goes in the parentheses here. So then again, I would distribute, and I would distribute both the negative sign and the 2. So this would become 3 minus 2x minus 2h. Okay. And again, what we can see is if I plugged in just x, I would get 3 minus 2x. If I add h to the x value, I subtract 2h from the y value. That's what happens when you have a line of slope -2. So it's allowing me to compare different points. If I change the x value, how does that change the output, or how does that change the y value? All right, in the next video, we'll work through questions 3 and 4. If you've got the worksheet printed out, you can go ahead and work those through before you tune into the next video. If you don't have the worksheet printed out, at the start of the next video, I'll have them up on the board for you here.